Okay, so I have to re-record this because there's a problem recording it earlier today, so this is what you saw earlier today. So 2012 B2. Okay, full screen. So here we have three sequences: un plus 1 equals 12 over un plus 1, u1 equals 5, and we have vn plus 1 equals 1/4 3vn squared minus 2vn minus 8, with v1 equal 2, and then wn plus 1 equals wn squared minus 2 wn plus 3, with w1 equal to 1. So we have our three recursive sequences, and we're told the first term in each sequence. So what I'm going to do is generate the first few terms in each sequence. So here is the u, the v, the w sequence. So we already know the first term here in each of the sequences. The first one starts at 5, the v starts at 2, and the w starts at 1. Right, so firstly, we put 5 into the formula. 12 over 5 plus 1 gives us the next one, 12 over 5 plus 1. So I get here 17 over 5, and then I put 17 over 5 in, 12 over 17 over 5 plus 1. Let's see what I get there. 12 over that 1 plus that, 77 over 17, and then if I do that again, putting it back into the formula, I'll get 281 over 77, and so on. Okay, the next one we put 2 in, so we have 1/4 3 times 2 squared minus 2 times 2 minus 8, so 2 goes in, and then the next term is 0, and then the next term looks like it will be minus 2 when I put it back into the formula, and so on. And then the third sequence here, the w, so I get 1 squared minus 2 times 1 plus 3, so it will be 1, 2, 3, 6, 27, 6, 7, 8, 4, 5, 8, 3, 3, 1, etc. Okay, so they asked which is the convergent, divergent, and periodic one. I think the easiest one to see which is periodic straight away is the v. You can see that v is the periodic sequence. Periodic means repeating. So this sequence is repeating itself. Next is the divergent sequence. I think that's clear that it's w here. The v is periodic, and the w is divergent. You can see it's getting really, really big really quickly. W is divergent. And so that would leave us with u being convergent. It's hard to see because it's fraction, but if you put them all into decimals it might be a bit clearer for you. So u is the convergent one here. Okay, part 2, so that was part 1. Part 2 now is find the limit of the convergent sequence, which we said was u. So the limit here is the limit of this sequence. So the technique here is to replace the u with x, multiply everything by x, so that makes it quadratic to solve. This is quadratic equation to solve. Let's see, two factors. X minus 4x plus 3. So we get x equals 4 or minus 3. Now what could the limit be? Well, if we go back to the sequence, we see that u is positive. Positive, 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 so it's reasonable to think at least that the limit is positive, and in fact it is positive, because if you look at that number there, 281 over 77, that is 3.65, so we can kind of see already that it's getting pretty close to 4. No chance of it going to minus 3. So we reject this answer and accept the minus 4. Okay, and that's part 2 done. A part 2 done, so now on to B. I'll just make this clear here. Okay. B part. You are told that the first, fourth, and 13th terms of an arithmetic sequence, the first, the fourth, and the 13th terms of an arithmetic sequence, are consecutive terms in a geometric sequence. So that basically meaning that the first, fourth, and 13th terms of an arithmetic sequence are the first 3 terms, we'll say, of a geometric sequence. Well, a equals a is not interesting. A plus 3d equals a or, and a plus 12d equals a or squared. You're saying that they're the same. Interestingly though, if you take the second term here and divide it by the first term, you get or. And if you take the third term and divide it by the second term, you also get or. And because these two lines are the same, it means if we take this term and divide it by a, we'll get or, and this term and divide it by the middle one, we'll also get or. In other words, that divided by that will be the same as that one divided by that one. So we end up making this equation: a plus 3d over a equals a plus 12d over a plus 3d. Cross multiplying, we have a plus 3d squared equals a times a plus 12d. So that means a squared plus 6ad plus 9d squared equals a squared plus 12ad. What's nice here is the a squareds on the left and the right cancels. 12ad minus 6ad, in total that's 6ad, and I have 9d squared left on the left. I'll divide both sides by 3d to simplify it. The d's cancel and the d will cancel the square. The 3 goes into 6 twice and the 3 goes into 9 3 times. So on the left I'm left with 3d, and on the right I'm left with 2a. A is left there. So I have a equals 3 over 2d. But you're also told in the question that the 6th term of the arithmetic series is 78. So that means a plus 5d equals 78. A simple substitution here will let you solve the problem. You now know that 3 over 2d plus 5d equals 78. So we get d equals, when we put these together and solve, 78. You'll get d equals 12, and then to get the a we just sub that back in. And I get a is 18. Okay, so the first term is 18 and the common difference is 12. Out of curiosity, I want to see what sequence that makes. So remember that the terms we were looking at were the first, fourth, and 13. So this is just extra, okay? The question's actually finished here. This is just for my curiosity. We have 18 as the first term. The fourth term will be 18 plus 3 times 12. That's 54. And then the 13th term would be 162. Okay. Yes, so for this arithmetic sequence, if you take out the first, fourth and 13th terms, you do actually make a geometric sequence. This is the first, this is the fourth, and this is the 13th term of an arithmetic sequence. If you take them out and put them together, you'll find that you do get a geometric sequence, that the terms are getting multiplied by 3. So this is definitely right.